Hello, my name is Sam from What the Hectagon Math Tutoring, and I'll be answering another question on Ask an Expert for Wyzant.com. So the question being asked is, find when an arrow hits the ground if it is launched upwards from a platform of 30 feet above the ground at an initial speed of 157 feet per second on Earth. Now, how are we going to figure this out? Well, if any of you have taken calculus, then you'll know that we can easily derive using the power rule and the idea of constant acceleration that you can describe projectile motion, in other words, falling objects, using this kind of quadratic equation where it reads 1/2 times the gravitational constant on whatever planet you're on times time squared plus the initial velocity of your object times time plus the initial height will determine the height of your object at any time t. Since we are on Earth, gravity pulls objects down at negative 32 feet per second squared. It's negative because they're going down, so we all sort of agree that up is the positive direction. And we were told that our initial velocity is 157 feet per second, and the initial height is 30 feet per second. So we can plug those values directly into our equation, and we see that the equation that describes the height will say h of t, in our case, is, well, what's 1/2 times negative 32? That's going to be negative 16 t squared plus an initial velocity of 157 times t plus an initial height of 30 feet. And we're being asked to find when this arrow hits the ground. Well, what does it mean for the arrow to hit the ground? That means the height is supposed to be 0, right? So we want to set this equal to 0, and we want to solve this quadratic equation. Now, maybe we want to know if we can do it with factoring. So what we should do is we should multiply these two numbers together. We should multiply 16 and 30. Negative 16 and 30, and see if that product can be broken up into two numbers that also add to 157, just like you learned in algebra class. So what is negative 16 times 30? Well, negative 16 times 3 is 48. I'm sorry, it's negative 48. So negative 16 times 30 is negative 480. So we want to find two numbers that we'll call S or R and S, right? Or we can call them X and Y. So we'll say we want X and Y, we want X times Y to be equal to negative 16 times 30, which we know is negative 480. And we want X plus Y to be equal to 157. So since our product has to be negative and our sum has to be positive, we know that one of our values for X must be positive. We know that, either X or Y, one of them must be positive and one of them must be negative. So we want to think of factors of 480 that differ by 157. So this might be a little difficult, but I think we can probably figure it out. In fact, it's not very difficult at all, because what is 157 but 160 minus 3? So we found our values for X and Y that we can break up our middle number into, and that's exactly what we're going to do. In other words, h of t can be rewritten as negative 16, that's a poorly drawn 6, negative 16 t squared plus 160t minus 3t plus 30. And now we can factor this expression quite simply. So we can factor negative 16t out of the first two terms. So we get negative 16t times the quantity t minus 10. And we can factor negative 3 out of the next two terms. So we get minus 3 times the quantity t minus 10. Now we have a common factor of t minus 10 that we can factor out. So we can rewrite it as, well, we can take that negative 1 out to the front. So we get negative 1 times the quantity t minus 10 times the quantity 16t plus 3. Now, since this is being set equal to 0, that means we can simply say that each of these individual factors can be set equal to 0, giving us the two solutions to our equation. From this factor here, we see that this is made 0 when t is equal to 10. And we can see that this factor is made 0 when t is equal to negative 3 over 16. But negative 3 over 16 is a negative amount of time, so this cannot possibly happen in the future, which means this solution is not something we need to consider. The answer, therefore, must be that the arrow hits the ground at t equals 10 seconds. Okay, that's the final answer. Thank you very much for watching.